Hello my dear students, good morning to you all. So in my last class I was explaining about Schrodinger wave equation. So what are the terms which we are going to use in Schrodinger wave equation? So to understand that, we had a brief introduction about what is meant by an operator and what is a Laplacian operator and Hamiltonian operator. So this Laplacian operator and Hamiltonian operator was used in the equation, so which we discussed in our previous class, that is the Schrodinger wave equation for an electron which propagates in 3 dimension in a space. Okay, so we deduced a equation and we also saw the simplest form, that was equation 3. So if you go back to the previous class or if you see in the textbook, so there equation 3, it was the simplest form of Schrodinger wave equation. So and also we understood that the Schrodinger equation can have number of solutions or wave functions, but all the solutions are not acceptable. So there was some conditions, okay, that conditions that has to be satisfied or followed, then only so we can accept the wave function, otherwise so it is not acceptable. And what are those 3 conditions? So that we discussed or understood in my previous class. And in this session we are supposed to understand about the significance of the wave function psi and psi square. So what is exactly a wave function? How you are going to define a wave function? So once after studying or understanding about the Schrodinger wave equation, definitely one has to define, or one should have enough knowledge about what is meant by a wave function. So as I said in the beginning classes of this quantum mechanics, so this is completely a physics topic. So let me define a wave function in terms of quantum physics. So a wave function is a mathematical description of a quantum state of a particle as a function of momentum, time, position and spin. So this is what is a wave function. In other words, so wave function has no physical significance because it cannot represent the probability of finding the electron in a small volume around the nucleus. So in terms of Schrodinger wave equation, or if we concentrate on the significance of the wave function, so then it has no significance, no physical significance, because it is very difficult in terms of an electron to find out where exactly so the momentum or the position or time and spin of that particular electron is going to be situated or located. The symbol used for a wave function is a Greek letter which is called as psi. By using a wave function, so what we are going to understand is the probability of finding an electron within the matter wave can be explained. So this can be obtained by including an imaginary number that is squared to get a real number solution resulting in the position of an electron. So the concept of wave function, it was introduced in the year 1925 with the help of the Schrodinger wave equation. So the basis for this wave function, which we call as a psi, okay, which is represented in a Greek letter psi. So the basis is Schrodinger wave equation, so which was introduced in the year 1925. Okay. So now with this brief introduction about what is wave function, let us understand the significance of the wave function. So as I said, wave function has no physical significance because it cannot represent the probability of finding the electron in a small volume around the nucleus. So just like how we saw in the previous class regarding the operator, so a mathematical operator, so it doesn't have any meaning. Okay, so if an operator written alone has no significance, in the same way if we represent a wave function without finding the electron in a small volume around the nucleus, it has no physical significance. So, wave function has positive as well as negative value, whereas the probability of finding the electron can be 0 or positive, but it cannot be never negative, because there will be a presence of electron. Definitely it can give the value of 0, otherwise it should give the value of a positive value, but can never be negative. Understood? So, this is because of the fact the wave function psi can have positive as well as negative value, whereas the probability of finding the electron can be 0 or positive, but can never be negative. The square of psi, that is the psi square, always has positive value and hence measures the probability of finding the electron. Okay. So, the regions of space around the nucleus where there is high probability of locating an electron associated with the specific energy is called as an atomic orbital. So, this is a basic of structure of an atom. If you understand the structure of an atom, so there the region or the space around the nucleus where there is high probability of locating an electron associated with the specific energy is called as an atomic orbital. An atomic orbital represents a definite region in 3-dimensional space around the nucleus where there is high probability of finding an electron of a specific energy E. So, these are all some of the significance of wave function. So, next let us move on to the postulates of quantum mechanics. So, what are the postulates of quantum mechanics? So, before understanding the postulates, let us briefly listen to the properties of wave functions. So, all measurable informations about the particle is available with the help of this studying the wave function. If we study the wave function, then we will get all measurable information about the particle is available. And next property of wave function is psi should be continuous and single valued. Using the Schrodinger equation, energy calculations becomes very easy, and probability of distribution in the 3 dimensions is established using the wave function. The probability of finding a particle, if it exists, is 1. So, these are some of the properties of wave function, just like how we made some points regarding the significance of the wave function. In the same way, so we can also make some points which describes the properties of wave function. So, now let us see what are the postulates of quantum mechanics. The formulation of quantum mechanics for the wave mechanical treatment of the structure of atom rely upon or depend upon a few postulates which, for a system moving in one dimension, say that the x coordinate are as follows. Mainly we classify the postulates of quantum mechanics into 4 different postulates. What are those? So, let us understand one by one. So, the first postulate says that the physical state of a system at time t is described by the wave function. So, wave function is represented as a psi. Okay. So, here x is a coordinate, okay. So, on which direction the wave is propagating, and t represents the time. Okay. So, the first postulate, what does it says is the physical state of a system at time t is described by the wave function, that is psi into x comma t. The second postulate is the wave function psi xt and its first and second derivatives. Okay. So, the first derivative will be delta psi divided by delta x, and the second derivative is del square or delta square psi divided by delta square x. Okay. So, this is the second derivative are continuous. So, this is very important. The wave function for first and second derivatives are continuous, and what else along with with that continuity, so they are finite and single valued for all values of x. Okay, so irrespective of the number of values which we are going to get by performing the calculation of Schrodinger wave equation of a particular wave which is propagating in a first and second derivative at x coordinate and at time t. So, it is continuous as well as finite, and it will have a single value for all the values of x. So, this is all about the second postulate of quantum mechanics. And what is about the third? So, the third postulate says that the possible values of an physical quantity of a system are given by. So, what are the physical quantity of a system? For example, the physical quantities of a system means so it might be a energy or it might be a angular momentum. Okay, so like this, etc. So, these are the physical quantity of a system. So, the possible values of any physical quantity of a system are given by the eigenvalues in the operator equation. Okay. So, the values of a physical quantity, what are the possible values it can take? So, that is given by the eigenvalues. So, what are eigenvalues? So, that we already understood in our previous class. So, the value of energy which is given by a particle in terms of eigenwave function is called as a eigenvalue. Usually these eigenvalues are acceptable values of a wave function. Okay, so the acceptable values are called as eigenwave function, and the value of energy which is given by the particular eigenwave function is called as an eigenvalue. So, here the third postulate clearly says that the possible values of any physical quantity, say for example, so the energy or the angular momentum are given by the eigenvalues in the operator equation. So, how we are going to represent it? With the help of an operator equation, that is A cap psi which is equals to E psi, where so A cap is the operator and psi is the eigen function. Or else, so this can also be written as operator and eigenfunction, which is equals to eigenvalue and eigenfunction. Okay. So, this is how where the A cap, which is operator which corresponds to the physical quantity, okay, and A is the eigenfunction, and in other words if we can say, so each single measurement of a physical quantity of A gives an eigenvalue of the operator A cap. Okay. So, this is what we are going to understand by studying the third postulate of quantum mechanics. And what about the fourth one? The fourth says that the expected average value. Okay. So, the average value or the expected value, both we can take, expected average value or expectation value. So, it corresponds to the operator A cap and is obtained by the relation. So, A which is equals to limits of infinite psi star A cap psi dx. Okay. So, here psi star, so this one is the complex conjugate of psi. Okay. So, this is the fourth postulate, and this is how we are going to represent or express it in a mathematical form. Okay. So, what is understood with this? By looking at this fourth postulate, so we are going to understand that, so the expected value, okay, so the expected value or the expectation value, so which is represented as A, okay, so which is smaller than or greater than. So, this is a symbol which represents the approximation or expected average value or expectation value, this represents. So, always the expected average value of an observable A, okay, so of an observable A corresponds to the operator A cap is obtained from this mathematical equation. And the fifth postulate is about, for every system, time dependent Schrodinger equation exists which is given by h cap psi is equals to I h delta psi into x t divided by delta t. So, here h cap is the Hamiltonian operator of the system. So, these are some of the the main important postulates of quantum mechanics. Okay. So, if we summarize the postulates of quantum mechanics, so what are the outcomes or what are the points which we can make out? So, with the help of the time dependent Schrodinger equation, the time evolution of wave function is given. Okay. For a particle in a conservative field of force system, using wave function, it becomes easy to understand the system. The linear set of independent functions is formed from the set of eigenfunctions of operator Q. So, here operator Q associated with the physically measurable property which is called as a Hermitian. By performing the expectation value, that is integral with respect to the wave function associated with the system, so the expectation value of the property Q can be determined. For every physically observed Q value, so there is an operator Q. Okay. So, the physical observable value can be represented as a small q. So, or the operator Q as operating on wave function which is associated with the definite value of the observable, such that it yields wave function of that many times. So, in this way we can summarize the 5 different postulates of quantum mechanics with respect to the Schrodinger wave equation. So, how it is going to help us? So, in what way so we are going to implement the Schrodinger wave equation to understand various different physical states of a system, and also so to study the property of the wave function, so which is continuous, finite and single valued, and it helps us also to know the possible values of any physical quantity of the system, such as energy or angular momentum, which is given in respect of eigenvalues in the operator equation, and also the expected average value. So, how the observable A value is calculated with the help of a mathematical expression. And also the fifth postulate where the time dependent Schrodinger equation exists, so which is given by an equation, that is h cap psi which is equals to I h into del psi into x t divided by del t. So, with the help of this time dependent Schrodinger wave equation, as I said, the time evolution of wave function is given. Okay. So, this is all about the significance of wave function and postulates of quantum mechanics. Okay. So, I am going to stop it here. So, in my next class we will understand about Schrodinger wave equation for particle in one dimensional box. Okay. So, this is very important and also very interesting topic which we are going to discuss in my next class. Okay. So, thank you dear students.